Hey guys, in this video we're going to talk about implicit differentiation, and so I have two equations that I'm going to show you guys how you would implicitly differentiate these. The first one is a little bit easier, and then the second one is going to be a little bit more complex, just to show you guys the basics of it and then a more realistic application that you would see on an exam. So this first equation we have is 4x squared minus y squared is equal to 1, and we are asked to find dy dx. So for this problem, we're asked to find dy dx. So we have 4x squared minus y squared is equal to 1. So when we're talking about differentiating, what we're mostly talking about is finding d over dx. And so when we're trying to find d over dx, what this means is that we're differentiating with respect to x. So x is the main variable in this equation that we're using to find our y prime. So when we're doing implicit differentiation, what we're looking at is we are looking at differentiating y with respect to x. So the main variable that you are differentiating with respect to x is shown in the denominator of your d over dx. So if you were to see d over dy, this would mean that you're differentiating whatever other variable is in your equation. So say we're looking at this equation again. Oops, I did not mean to erase that. Oh my god. Okay. So let's say we're looking at this equation again and we're differentiating d over dy, so we're differentiating x with respect to y because y is what we have in our denominator here. And then if we were to see d over dt and we're asked to find dx over dt or dy over dt, then you're usually given an equation and you're going to take the derivatives of whatever your x variable is and your y variable with respect to d over dt, so with respect to whatever your t variable would be. And since it's in respect to that t variable, anywhere that you differentiate x or differentiate the variable y, you would tack on this dx dt for your x variable or this dy dt for your y variable. So I know that might sound a little bit confusing, but I'm going to show you guys what exactly I'm talking about when we're looking at this problem. So there's going to be a couple main steps that we're going to follow when we're looking at these. So we're finding dy dx for 4x squared minus y squared is equal to 1. So the steps that we're going to do is, so our step 1 is going to be multiplying everything in the equation. Sorry, my cat is meowing really loud. Bud, stop. Okay, whatever. Multiplying everything in the equation by d over dx, because for this problem we're differentiating with respect to x, so we're multiplying everything in the equation by d over dx. So I'm going to take this and I'm going to put d over dx out in front, and then I'm going to distribute that to everything in my equation. And so what that shows is that I am taking the derivative of each little element or each little piece of this equation here. So we have d over dx times 4x squared minus y squared times d over dx is equal to 1 times d over dx. And so now step 2, the next thing I'm going to do is I'm going to take the derivative of each term, and anywhere that I have a derivative of y, because remember for this equation we're differentiating y with respect to x, so anywhere I have a derivative of y, I'm tacking on or adding dy dx onto that term. So that's a little wordy, but basically what this is saying is, so we have d over dx times 4x squared. So if we take the derivative of 4x squared, we get 8x to the first power. So this is a variable x. So we're taking the derivative with respect to x, so we don't need to tack on a d over dx here. But now for our second term, if we take the derivative of y squared, we get 2y, but we took a derivative of y, so now we have to tack on that dy dx, and then this is equal to the derivative of 1, which is just 0, because the derivative of a constant is 0. And so now I'm going to take this and do my final step, which my final step for this is going to be step 3, which is isolating dy over dx, because remember, we're asked to find dy dx, so we're finding what dy dx is equal to, and so now we're going to isolate the terms in order to get dy dx alone so we can say what it's equal to. So I can add 2y dy dx to both sides. So I get 8x is equal to 2y dy dx. Now let's divide by 2y on both sides. So I get 8x over 2y is equal to dy dx. So 8 divided by 2 is 4, so I should get 4x over y is equal to dy dx. And that is how I would do that first problem. So now let's go to the second problem, which this problem is a little bit more complex. And this is a better example because this is something that you're more likely to see on an exam because it's slightly more complex, but it's nothing super crazy. So we have y times cosine x is equal to 3x squared plus 2y squared. And we are asked to find dy dx. So looking at this, I have this y times cosine x is equal to 3x squared plus 2y. I'm going to multiply everything in the problem by dy dx, or I'm sorry, by d over dx, because that is my step 1. So I'm going to distribute this d over dx to each term. And then my step 2 is taking the derivative of each term. So I have d over dx times y cosine x is equal to the derivative of 3x squared plus the derivative of 2y squared. So now looking at this, I'm going to leave this left side alone just for right now while I work a little bit on the right side, and then we're going to come back to the left side. So if I take the derivative of 3x squared, that is going to be 6x, and I don't have to do anything with this d dx. I just took the derivative with respect to x. I took the derivative of x with respect to x, so there's nothing I need to change there. But now for the second term, I'm taking the derivative of y with respect to x. So 2 times 2 is 4, so I'm going to have 4y, but now this is a derivative of y again with respect to x, so I'm going to need this dy dx tacked on here. And now let's go back to the left side of the equation, because for this I'm going to need the product rule because I have one function multiplied by another function. So when I take the derivative of two products, I get the derivative of f times g plus f times the derivative of g. So now if my f is equal to y, and my g is equal to cosine x. I'm going to do this in a different color just to kind of really show what we're not doing. We're doing kind of like a little side part of the problem right now. So my f is equal to y, my g is equal to cosine x, my derivative of f is equal to 1, but remember I'm taking a derivative of y with respect to x, so I'm going to have to tack on this dy over dx here, and then my derivative of g is negative sine x, and we're taking a derivative of x with respect to x, so we don't need any dy dx or anything there. So now plugging this all in for the left side using the product rule, the derivative of the derivative of f is dy over dx times g, which is cosine x, plus the derivative of g, which is negative sine x, times f, which is y, is equal to 6x plus 4y dy over dx. So the really important thing to see with some of these product rule problems is just because you have a y term, you don't need the dy dx unless you're differentiating with respect to x. So if you do not take the variable of a y term for a certain step, for example, this product rule problem, then you do not need to tack on that dy dx. So now we're going to isolate. We have dy over dx cosine x minus sine x times y is equal to 6x plus 4y dy over dx. So we're going to do our step 3, which is isolating dy dx. Oh my god, I keep pressing the wrong thing. Okay, there we go. So step 3. So we can add y sine x to both sides. So we get dy dx cosine x is equal to 6x plus 4y dy dx plus y sine x, and then we're going to subtract 4y dy dx from both sides. So now we get dy dx cosine x minus 4y dy dx is equal to 6x plus y sine x. And then now let's pull out a dy dx. So we have cosine x minus 4y is equal to 6x plus y sine x. Now we can divide both sides of the equation by this cosine x minus 4y. And we get dy dx is equal to 6x plus y sine x divided by cosine x minus 4y. So as you can see, these problems, once you kind of get the steps down, I actually think they're kind of fun, and they're not super crazy. Just make sure that you're tacking on, again, anywhere that you take a derivative of a y term with respect to x, you're tacking on that dy dx. If you're taking a derivative of x with respect to y, you'd be tacking on dx dy. Anytime you have an x term, just pay attention to your terms, pay attention to all of your algebra here, because a lot of it in the end just ends up being simplifying.